Hey students, this is lesson 3.6. In this lesson we're going to learn how to construct parallel and perpendicular lines. Go ahead and do the review and I'll check back with you. Alright, so the first thing we're going to learn how to do is draw a line that's parallel to another line that's through a certain point. I'm going to need this tool, my compass, and so I'm going to do this one right here. I'm going to draw a line parallel to line L that's through point N. Now the way I'm going to do that is by using a theorem or postulate that deals with parallel lines. And one of those is if corresponding angles are congruent, then the lines will be parallel. So to use that one, I need a transversal. So I'm going to take a straight edge and draw a transversal. Then I have to ensure that my corresponding angles, I could draw this line in, anywhere like this. And as long as these two angles are the same, they would be parallel. And I can use my compass to ensure that they're the same. So I'm going to do that now. I'm going to draw an arc to represent my angle here. And so and it just accidentally went through the point N. It's not supposed to go through the point N. In fact, I think I'll redo that just so that you don't get the idea that it has to go through there. So let me make it a little wider. All right, there's my arc there. Now reproduce that arc with the point on N. Like that. So I didn't change my compass setting there. And then use your compass to measure that width. I have to open it up a little bit wider, so put a little arc there so that I know you did that. And then we can measure that on our other arc. So if we have the same arc length, then we'll have congruent angles. And then I can just draw my line through N and through that other point there, where the two arcs intersect. And by doing that, I have ensured that this angle and this angle are the same, and those are corresponding angles. And if corresponding angles are congruent, then the lines will be parallel. All right, I'm going to let you try that. Actually, I'm going to show you how to do it using the alternate interior, converse of the alternate interior angles theorem. You can go ahead and try that. Think about that if you have your compass. Otherwise, you can check how I did it, and you should be able to tell from my work that I use alternate interior angles here. All right, in this construction, I drew a transversal first through point P that intersected line N anywhere. Then I created arcs to make sure that these two angles would be congruent. And so now I'm using the converse of the alternate interior angles theorem to create these. All right, answer these questions, and I'll check back with you. All right, in this example, we're going to actually construct a quadrilateral. We want one pair of parallel sides. So one set of parallel sides, that's a trapezoid. And the sides, those parallel sides, should have these two lengths, A and B. So let's just start by drawing an arbitrary line. And let's use our compass to create a segment of length A on that line. So all I have to do that is measure that line. Measure length A using my compass. I have that length now. And let's put a point on here to start from, and that's going to be point A. And then I'm going to use that same measurement with my compass to get point Z. Okay, now I'm just going to draw a transversal. And pick a point anywhere on that transversal. Don't go too far up though, so that you end up going past Z. But So now I'm going to draw a line. I need a parallel line. I need a line of length B that's parallel to AZ. So to do that, I'm going to use the corresponding angles postulate and draw an arc. And go up to my point. This is actually point B right here. And draw that same arc. And then use my compass to measure the size of that arc. Right there. Reproduce that on the other arc. Okay, so I reproduce that arc. And then if I draw a line through that, through the point I drew B and the end of that arc, I should have parallel lines. Actually, I will have according to the postulate. Sometimes if you make arcs too small, it's really hard to get the measurement perfect, so your lines might not look quite parallel, but if you did it right, it should be good. And now I just have to measure the length B with my compass. There. And reproduce that on that line. And label that point Y. And then draw in, use your straight edge to draw in one more line from Z to Y. And you now have a trapezoid that has parallel lines that are lengths A and B. All right, so I'm going to let you try that. All right, problem 3, construct the perpendicular to a given line at a given point on the line. So we need to construct a line perpendicular. So I just reproduced this drawing here, and I'm going to draw a line through point P perpendicular. Now to get it to be perpendicular, what I'm going to do is just create the perpendicular bisector, basically. I think that's the easiest way to do this. You could do a parallel line thing, but I think this will be easier. So I want equal segments on both sides. I'm going to draw that in. And then if I draw perpendicular bisector, I know that that line will be perpendicular. So I'm going to open this a little wider. And just draw an arc there. Draw an arc up here. Move it over. Oops, I missed that arc. And then I need one more arc. And now, if I draw a line through those intersections of those two arcs, I should have a line that's perpendicular. And actually, with your straight edge, you can just go from point P up. And I probably didn't need both sets of arcs to do that, so if you want to save yourself a little time. There we go. And this line we're going to call CP, and CP is perpendicular to line L. All right, I'll let you try that. You can do the same thing I did there. And you can check back with your answers. Okay, the first thing you would do is just draw any arbitrary line with point F. Then step 2, you would draw EF so that, and FH so that EF is congruent to FH. Then you would draw point G using the same length arcs from E and H. And then you can draw a line GH, and that should be perpendicular. I don't know what step five would be. All right. Here's a postulate we're going to use, the perpendicular postulate. Through a point, not on a line, there is one and only one line perpendicular to a given line. So the diagram that models this is through a line, there's only one line that's perpendicular, so I think that would be this one. We got the perpendicular in the middle there. So we're going to do one more thing here. We're going to construct the perpendicular from a point to a line. So given line L and point R not on L, we're going to construct RG with RG perpendicular to L. Okay? And to do this, we're going to use our compass. And we're going to just put our compass on point R and open it up. And draw an arc, and actually I'm going to continue this arc all the way around. Okay, and then I have 2 points that are equidistant from R. Now I can use those 2 points to draw an arc that is equidistant from both of those points on that other arc. And since R is equidistant from this point and this point, and it's also, and this point out here, which is G now, is actually we don't want that to be G, but that point is equidistant from here, from this point up here, and this point up here again. We have assured that it's on the line that's perpendicular, so I can just draw a line now through R and through that other point, and it is guaranteed to be perpendicular. So G is right there. All right, we can try that. All right, go ahead and do the lesson check, and I'll see you next day in class.